this is team 13. Now we're going to describe the lab assignment 2, and the first lab assignment is to implement one of the naive-Bayes theorem on the data sets, and then show the different kind of plots between the prediction and the categories. So if you see this, we have applied Gaussian naive-Bayes on the data set, and the data set that we have taken is diabetes. So if we run the thing, we get the output as follows. So the accuracy is 0.50%. So if you see, this is one kind of plot where it gives the count is the prediction and age is one of the categories. So this is one plot. So this is another plot where it gives the plot between the count, that is the prediction, and the sex. And there are different kinds of categories in this data set, and one is BMI, and this is plotted against the count, that prediction. So in this way all the predictions are done. So this is how the first question was completed. And when we go to the second question is about loading the data and then applying RBF kernel and polykernel. So it is a kind of SVC model where the SVC model is applied, and it is to compare two kernels. One is polykernel and the other one is RBF kernel. So we applied all those things on the dataset, and the dataset we have used is diabetes, the same dataset. So if we run this, we get the output as follows. In this format, the two outputs are shown. So here it shows in the output it shows the accuracy of both the models. So if you see the accuracies, RBF kernel gives more accuracy when compared to the poly kernel. So this is the plot. This is the plot of this question with the data sets, like the diabetes data set on this thing. So this is how the second question was done. So if it comes to the third question, it is like implementing the stemmer and lemmatization on the words, and then tokenization is done. So the question is all about finding the bigrams, and then concatenating the strings that contains the most repeated bigrams. So here the dataset that we have, here the input was given in another folder. This is the input folder that is given in text format. So this is given as input to this third question. So here if we run this, we have created tokens and sentence tokens and word tokens, and lemmatization is applied to the words, and the output will be shown in the thing. So here we have applied bigrams, and then the most repeated bigrams and the top 5 bigrams in the list are shown with this code. So the concatenating the strings, like the sentences which have the most repeated bigrams, is obtained by using this code. So if we run this code, we get the output as follows. So here you can see the output. Here this is the tokens that we have used, and bigrams is as follows, is here, and the most repeated, the first 5 bigrams can be seen here, and then here it is the concatenated array of strings, like the sentences which has the most repeated bigrams. Hence the third question was done. So in this way it was completed. So if it comes to the fourth question is all about applying KNN. As KNN, we know that the accuracy differs by differing the K value. So here we have taken K as 10, and this code gives you the plot of accuracy with the K values, like the plotting between K and the accuracies with respective Ks. So if you run this, you can see the output as follows. So this is the accuracy with the case. So if the k value ranges from 0 to 50, so the accuracies are in this follows. It completely depends on the data set, and the model also divides the data set into training data set and testing data sets. It depends completely on it, but as we know, the k value increases, the accuracy increases. It increases like this. So this is how the fourth question was done. Thus a lab assignment was completed successfully. Thank you.